In episode 56, titled Protect Sensitive Data, RBAC, Encryption in Transit, Encryption at Rest, the theme is layered protection that reduces exposure even when a single control fails. Sensitive data rarely leaks because one person made one mistake. It leaks because multiple small weaknesses lined up at the same time. Strong protection is built from overlapping controls that each remove a portion of risk, so a missed setting or an unexpected access path does not become a full incident. When these layers are designed deliberately, teams can move fast while still keeping sensitive information from drifting into places it does not belong. Sensitive data is best defined through classification and business impact rather than through a narrow list of field types. Some data is sensitive because it identifies a person, such as PII, while other data is sensitive because it reveals operations, finances, intellectual property, or security posture in a way that could cause harm if exposed. Business impact is the practical lens because it ties the label to real consequences, like customer trust loss, fraud risk, regulatory exposure, or competitive damage. When classification reflects impact, teams can explain why certain datasets receive tighter access, stronger monitoring, and stricter retention without turning the conversation into guesswork. Role-based access control, RBAC, is the mechanism that makes access decisions predictable by tying permissions to job roles rather than to individual convenience. A role represents a set of responsibilities, and permissions represent the minimum data access needed to carry out those responsibilities in a controlled way. This matters in reporting systems because dashboards often pull from shared datasets, and shared datasets are where overbroad access quietly becomes normal. When RBAC is applied consistently, the organization reduces the number of people who can reach sensitive fields and increases confidence that access aligns to purpose. Least privilege is the principle that makes RBAC effective because it keeps roles from turning into everything access over time. Least privilege is not only about limiting who can see data, but also about limiting what they can do with it, such as exporting, sharing, or drilling into row-level detail. In practice, least privilege improves decision quality because it encourages teams to publish aggregated views for broad audiences and reserve detailed views for narrow, well-justified use cases. It also reduces accidental exposure, since many leaks happen through routine sharing paths that were never meant to carry sensitive detail. Encryption in transit protects data while it moves across networks, which is one of the most common places where data can be intercepted or altered if protections are weak. The practical goal is confidentiality and integrity during movement, so the same dataset that is safe inside a controlled store does not become vulnerable during transfer between systems, services, or user interfaces. Transport layer security, TLS, is often the standard mechanism that provides this protection, and its value is strongest when it is consistently enforced rather than used only on important connections. When encryption in transit is treated as normal, the organization reduces the chance that routine data movement becomes the weak link. Encryption at rest protects stored copies, including primary stores, replicas, and backups, which matters because stored data often outlives its original use and becomes a target of opportunity. At-rest protection reduces harm when storage media is accessed improperly, when backups are exposed, or when a lower trust environment inherits data it should not have received. Encryption at rest does not replace access control, but it adds a strong layer that limits the blast radius of certain storage failures. When teams consider that backups count as stored copies, encryption at rest becomes part of retention discipline as well, because protected storage is still exposure, just reduced exposure. Key management is the part that often determines whether encryption is truly strong or merely present, because weak key practices can undermine otherwise solid cryptography. Keys need controlled creation, limited access, clear ownership, and policies for rotation and revocation so they do not become long-lived secrets that drift across teams. A managed key service, sometimes called KMS, can help centralize these practices, and a hardware security module, HSM, can further strengthen protection for high-impact keys. But the critical idea is that keys must be treated like sensitive assets. When key custody is unclear, encryption becomes harder to trust, and investigations become harder to complete, because nobody can confidently explain who could decrypt what and when. A shared analytics dashboard scenario makes these layers feel real, because analytics dashboards are designed to be broadly useful, and broad usefulness can collide with sensitivity. Imagine a company-wide dashboard that shows customer activity, revenue movement, and support trends, where leaders want fast visibility and teams want self-service exploration. In that environment, RBAC can keep sensitive fields, such as direct identifiers, limited to approved roles while still allowing aggregated views for general audiences. Encryption in transit and encryption at rest protect movement and storage behind the scenes, while least privilege keeps drill paths from becoming a shortcut into row-level detail that was never meant for broad access. Access logging is what turns protection into evidence, because investigations and audits depend on knowing who accessed what, when, and through which pathway. Logs should capture the identity used, the resource accessed, the time, and the outcome, such as allowed or denied, so suspicious patterns can be detected and routine access can be explained. Logging also discourages misuse, since visibility changes behavior, especially when people know access is monitored and reviewed. When logging is consistent across the reporting stack, teams can trace a data exposure question back to facts rather than relying on assumptions about how the system probably works. Environment separation reduces accidental leakage by keeping development, testing, and production concerns from blending into one shared space. Many data incidents occur when production data is copied into lower control environments for convenience, then retained longer than intended or shared more broadly than expected. Separation also supports stronger change control, since production reporting paths can be governed more tightly while experimental work stays contained. When environment boundaries are clear, it becomes easier to apply different retention rules, different access rules, and different monitoring intensity without creating an inconsistent story about protection. Credential rotation and rapid revocation matter because access changes are constant, and stale access is one of the most common sources of unnecessary exposure. People change roles. Contractors roll off, service accounts evolve, and projects end, and each of those moments should reduce access, not preserve it by inertia. Rotation reduces the window of opportunity if credentials are compromised, while revocation reduces exposure when access is no longer justified. When these practices are tied to identity lifecycle events and supported by clear role definitions, the organization avoids the slow accumulation of ghost access that auditors and incident responders tend to find later. Control validation keeps the layers honest, because protections that exist only in design documents do not reduce real-world risk. Periodic reviews can confirm that roles still match responsibilities, that sensitive datasets are still classified correctly, and that encryption settings remain consistent across new replicas and new pipelines. Simple tests, such as checking whether data transfers consistently use encrypted channels and whether stored datasets are protected as expected, catch drift early without requiring dramatic forensic work. When validation is routine, trust increases because stakeholders see a pattern of controlled behavior rather than a one-time setup that nobody revisits. A defense checklist can be carried as a narrative that begins with classification, then moves through access control, encryption, keys, evidence, and operational hygiene in a repeatable order. Classification sets what needs protection and why. Then RBAC and least privilege define who can see which level of detail, and encryption covers movement and storage so data is protected in motion and at rest. Key management supports encryption strength. Logging provides accountability and investigation evidence, and environment separation reduces accidental spread into lower trust zones. Rotation, revocation, and periodic validation keep the system from drifting as people, pipelines, and platforms change. To conclude, one practical habit is choosing a single access review to schedule this week and treating it as a routine reliability practice rather than as a compliance chore. The review can focus on one high-impact dashboard or one sensitive dataset and confirm that the roles, permissions, and drill paths still match the intended audience and purpose. It can also confirm that access logs are available and that encryption expectations remain intact for storage and transfers tied to that artifact. When one review is completed and recorded consistently, it becomes the seed of a repeatable control rhythm that strengthens protection across the entire reporting environment. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.